Okay, guys, this is the review for your wonderful and glorious take-home assignment that you have over spring weekend. Now, what I did was I created an assignment identical to yours. I took my program, I generated 12 more questions, exactly like what you've got, and I'm going to go through it. My question one said this: the sixth root of 128, p to the second, q to the fifth, r to the third. Now, what I need to know is the troll toll here is a whopping 6. That means I need to break everything up into the 6th power. And so I take the first number. All right, what's 2 to the 6th? That's 64. Does 64 fit in evenly into 128? Why, sure it does. 2 to the 6th times 2. Now, the problem is none of these variables here can pay the troll toll. The toll is 6. They all have less than that. So the only thing they can leave is right there, that 2 to the 6th. It pays the exponent to the troll toll and walks out. Everything else is stuck. There's the answer for number 1. Number 2, the cube root of 135, m to the second, p to the third, and q. All right, look, all right. Try things that are to the third power. Hey, does 2 to the third or 8 fit in there evenly? No. How about 3 to the third, which is 27? Why, sure, that does fit evenly in there. 27 times 5. The troll toll is 3. The only thing that can pay that toll is, in fact, that p. P to the third. A p to the third walks out as a p, and then that 3 to the third. That base walks out. Everything else is stuck under there. There's your answer for number 2. Now, this one's a little trickier, I admit. It's to the 4th power. I want things to the 4th power now. Well, can I break apart things to the 4th power? Why, sure I can. What is 2 to the 4th power? It's 4, 8, 16. Does 16 fit in there evenly? No, it doesn't. Oh, man, I got to go to 3 to the 3rd power. That's 81. Does 81 fit in evenly? Why, sure it does. 81, which is 3 to the 4th, times 3. Why'd I pick to the 4th? Because my troll toll is a 4. Right there, it's a 4. So I break all of these things apart into pieces of 4. I can break that q to the 6th as q to the 4th and q squared. That r to the 5th as r to the 4th times r. Now, what is r to the 4th as it walks out? An r. What is that q to the 4th as it walks on out? A q. 3 to the 4th as it walks on out? A 3. And why is that? Because the troll toll is, in fact, 4. Everything else that can't pay, the 3, the p squared, the q squared, and the r, all are stuck underneath. All right, now 250 here. 250, m to the 3rd, p to the 6th, q to the 6th. Troll toll being 3. All right, what to the 3rd power fits? It ends in a 0, so usually that keys us into that 5, and it is. 5 to the 3rd, which is 125 times 2. And I break the rest of these parts into pieces of 6. Now, with variables, remember, we add their exponents, so 3 plus 3 is 6. What can pay the troll toll? The m to the 3rd. 2 p's can pay, so p squared leaves, and 2 q's, so q to the 3rd. And obviously that 5. Next on the docket. Whoa, 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 whoa. 486. Wow. Well, luckily for me, when I try a 3 to the 4th, which is 81, and I divide that in, 81 times 6. The troll toll is 4. So I break that m to the 5th as an m to the 4th and an m. P to the 3rd and a q to the 4th. And what can leave? A 3, that m, and that q. They all pay their exponents as they walk on out. All right, these are all square roots. We're just combining like terms here. Now, what you got to do first is you got to break them apart as much as you can. This first one, can't break it apart. The second one, can't even simplify it. This third one, though, negative 2 times the square root of 18, I can break root 18 down as 9 and 2. Now, why in the world would I do that? Well, remember, folks, the square root of 9 is 3, and negative 2 times 3, negative 6. And then obviously I can't break that one down. I combine like terms here. Now notice the things in orange, they're not there. Why? I have 3 of something. I take 3 of that something away. I'm left with nothing. I have 2 apples. I take away 6 apples. I'm negative 4 apples. Even more simplification here. All right. The square root of 27. Write down as 9 and 3, because the square root of 9 is 3, as from the previous example. 2 times 3, 6. Here, 24 breaks down into 4 and 6. Why in the world would I do that? The square root of 4 is 2. Negative 2 times 2, negative 4. Here, 9 and 6, multiply to 54. Again, the square root of 9 is 3. 3 times 3 is 9. And 12 breaks down as root 4 and root 3, breaking down into 2 root 3. And then you simplify your like terms. 6 and negative 2 make a 4. Negative 4 plus 9 is a 5. Again here, breaking these down as much as I can. That's square root of 8. Root 4 and root 2. So you have negative 2 root 2. 150. 25 and 6. And 25 is 5. 5 times negative 3, negative 15. And again, 50 breaks down into 25 and 2. We all know what root 25 is. You combine your like terms here. 2 root 2, negative 15 root 2, negative 13 root 2. 2 root 6 minus 15 root 6. That's a little mistake there. Well, right there. Negative 13 root 6, and then these two make a negative 17 root 6. All right, the exponent properties. Remember, you multiply coefficients, add exponents. So multiply 3 times 3 and get 9. I have p to the negative 1/4, p to the second. Do the work over here. Need a common denominator. 2 over 1 means 8 over 4. Add across the top, 7. And then that q has no friends. Boom. Remember, negative exponents, we can't have them. We don't have any, so I'm done. Here, when you have power to a power, you multiply. 7 times 1, 7. 2 times 4, 8. Done. 2 times 1/2, 1. This one's even trickier. This is a quotient property. First off, we divide 2 by 2 and get 1. Then we take h squared and h to the negative first. We subtract our exponents there. 2 minus the negative 1, 3. J to the 3/4 has no other combinations. Boom. K to the 4/3 minus 1/3. Numerator minus denominator. 3 over 3 is 1. And now, the piece de resistance. Alrighty. I'm going to simplify the top part here first. So what I do is I take and multiply the coefficients, 4 times 3, and get 12. Y and y to the negative second, make a y to the negative first. 1 plus a negative 2. Then I have x to the 5/3 and x to the negative 1/2. Do the work over here. Add across the top and get negative 7 over 6. And here, I have a z to the 4th and a z to the 3/2. Common denominator and add. Boom. Now nothing really happened to the bottom. Now I go to work. Again, it's like the last problem. We use our division, our quotient properties. So 12 divided by 2, 6. Then I have x to the 7/6 minus a negative 1. Numerator minus the denominator. Minus the negative becomes a plus. Now I didn't do the work here, but 7 over 6 plus 1 is really 7 over 6 plus 6 over 6, which is 13 over 6. 11/2 minus 3/4. I do the work over here for you. Common denominator, 22 over 4. Minus 3 over 4, 19 over 4. And now, why do the work here? Why do the negative first? When it's negative, you can do the quotient property or just flip the fraction to the denominator. Now, this take-home assignment will be on the 4th. Yes, 4th marking period now. I hope this is helpful for all of you. There will be a copy on D2L, and this will go on the YouTube channel, obviously, that you already found it. If you have any questions, please email me. Thank you. Happy spring weekend.